Okay, so today we're going to continue to talk about area, but it's going to get a little bit trickier, as it always does, because our brains are growing and we need to challenge them. So now we have shapes that are much more complex than our simple rectangles. This shape right here is, I don't even know what to call that. I really don't. It's like something with a bite out of it and a hole in the middle. So finding the area of something like this is definitely trickier, but we can still do it. We can still do it. I know that we can. I'm going to pick a color here and we're going to try to figure out how many whole squares do we have that are shaded in. So I'm talking about these orange ones, not the white ones. Okay, so think of this like a hole in this shape. Well, I have this. Oh, this is, here we go. 1, 2, 3, 4, 5, 6, 7. Do you see how I didn't count this? Because this is not a whole square that's shaded in. And same with these other ones. But I had 7 squares that were completely shaded in. Now I want to figure out how many half squares. So I'm going to use a different color. How many half squares are shaded in? Here's a half. Here's a half. 1, 2, 3, 4, and 5. I found 5 half unit squares that are covered by this figure. So I have 7 holes and I have 5 halves. Interesting. 7 holes plus 5 halves. Well, I can't just add those two numbers together because we know that this is not a hole down here. We're talking about 5 halves. So how many is 5 halves anyway? We've never learned how to add fractions. So let's draw a picture to think about it instead. Here I'm just drawing holes for you to just see for my picture. Watch what I do. I'm going to count 5 halves. 1 half, shading it in, 1 half. 2 halves. 3 halves. 4 halves. 5 halves. I have shaded in 5 halves, okay? 1, 2, 3, 4, 5 halves. Not 5 holes, 5 halves. Together, it equaled 1 hole, 2 hole, and this still isn't a hole, so this is just a half. So together, 5 halves is the same as saying 2.5 holes. Okay? Now, this is the number that I can add with the 7. 7 plus 2.5 is the same as 9.5. So this shape is 9.5 square units. Let me check my work. I was correct. If there are 7 holes and 5 halves, then that means that this figure is 9.5 square units. Now, I bet that second part was confusing for you. This part right here might have been confusing for you. So we're going to keep going and we're going to see if that comes up again so that we can review that. Okay, we're going to find the area of both of these figures shown, and then it says which figure has a greater area. So first we need to figure out the area of both shapes and then compare them. Let me get my pen out. First, we're going to count the holes. 1, 2, 3, 4, 5, 6, 7, 8. 8 holes. Now I'm going to count my halves. 1, 2. 2 halves. Here's a picture that I'm going to draw. We know that we need 2 halves. So I'm going to cut it in half. Then I'm going to color in 2 halves. 1 half, 2 half. How many holes did I just color? Well, this whole thing is colored in. That means that 2 halves equals a whole. That's something that you should probably already know, but just to show you the picture. 2 halves equals 1 whole. So I'm adding 8 plus 1 more because these 2 halves equal 1. That means that the area of this shape right here is 9 square units. Don't forget, square units. I'm not going to write it out, but you should. Square units. Now I'm going to find this one. Let me go back to red to find my holes. 1, 2, 3, 4, 5, 6 of these squares are holes. Now I'm going to use purple to count my halves. 1, 2, 3, 4, 5, 6 halves. Well, 6 halves is not the same as saying 6. 6 halves. Watch. I just made 6 halves, if you're paying attention. 1, 2, 3, 4, 5, 6. I colored in 6 halves. 6 halves equals 1, 2, 3 holes. So that's what I'm adding to 6. 6 holes plus 6 halves. 6 halves equals 3. So 6 plus 3 is 9 square units. So I have 9 square units over here, and I have 9 square units over here. So if I need to compare them, which one has a greater area? Well, neither. They are equal. That's how I compare them. Let's check our work. The figures have the same areas. The area of each figure is 9 square units. Okay? Let's look at this example. In art class, Haley drew the figure at the right on grid paper. What is the area of the figure that Haley drew? First, we need to count the number of whole squares, then we need to count the number of half squares. Remember, 2 halves equals 1 whole. So here they counted for us. Well, they didn't tell us, but they tallied them. It's really, really helpful to mark them with a pencil as you're counting them so that you don't count them 2 times and so that you don't miss any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 holes and 2 halves. 2 halves equals a whole. So 14 holes plus 2 halves equals 14 plus 1, which means that the total area should be 15 square units. And that is correct. We're going to skip through some of these because I want to get to one like this. So here we have a geoboard with a rubber band on it. There's no lines, but I think that you can see the similarity between these. So we have, if I just draw lines, that might help you. Go ahead and do that if that helps you on yours. How many holes? 1, 2, 3, 4. 4 holes. How many halves? 1, 2 halves. 2 halves equals 1. 2 halves equals a whole. 4 plus 1 equals 5 square units. So the answer for this one is 5 square units. What about a triangle? Ooh, fancy, huh? How many holes? Always start with holes. 1, 2, 3 holes. And how many halves? 1, 2, 3 halves. Oh no, 2 halves equals a whole. So if you add these two together, they become 1. And then there's still this extra half that you can't add to anything. So add the 1, we'll get 4, but we still have this half right here. So 4 and a half. 4 and a half square units, 5 square units. And those are correct.